Continue. Now, the next question said, okay, she's here. Now, the next question says, explain why refractive index does not have a unit. Explain why refractive index does not have a unit. Okay, is there any reason? Anyone?
I think it's probably because we're dealing with angles. So
Okay, Ella, are you there? Ella, are you there? Okay. Um, okay, Ella, are you there? Okay, now explain why refractive index does not have a unit. Refractive index does not have a unit is because we are using the ratio of two identical units. I mean, two identical quantities. We are dividing the ratio, or we are using the ratio or the division of two identical unit quantities, two identical quantities. So because there's a division,
we're talking about.
did you get me?
I mean, I think
Yeah.
too.
What are you saying? I can't hear you. Okay, because we're looking at the division of two. So that's the reason why, or that's the reason identical refractive index does not have a unit. Okay, I hope we are clear on that. I hope we are clear on that. Okay. Um, okay. Okay. Anyone? Now I guess that's all. That's the end. That's okay. Let's continue to the next one. Um, they said a ray of violet is incident on the prism along the same path of the red. Sketch to this when a ray of light incident dispersion produces a continuous spectrum of color. State how the speed of light depends on its frequency and explain how this is shown. Okay, they asked us to do red, violet. Hey, hello, can anyone hear me?
Yes, sir.
Yeah.
Okay, remember after we did that part, remember this is red. Please make sure you also do sorry, let me
Um,
change this.
so I think we were
This should be violet. Now
valid. Yes.
red, remember violet comes down, and remember red comes this way. All right, so you should,
So,
yes.
so in the drawing of the incident violets, I think that there should be more space between the red and the violet because normally there will be more there are other colors in between red and violet,
And no,
and the
we are
space.
just doing that to illustrate that one is violet also and one is red. Actually, they should be the same space, but you know, if we draw that on it, it will look orderly. That was why
No,
Sample
that's
the
so
you said.
that's not what I'm saying. I'm saying like, so I'm saying that the distance between the red light and the violet light is really small because like
Do you
the
mean is it incidence or refraction?
incident.
Yeah, it's really small, definitely now because they are all coming into that prison. That's what I'm saying.
Sorry.
It's because they're coming to
So,
that prison. They are incidents together in the prison.
so
Yeah, what I
aren't
don't.
you supposed aren't
Uh,
you supposed to draw the light inside the prism?
no, inside.
The violet light.
No.
No, it's
It
written
should.
there.
This is indicated red. Okay. I think I get what you're saying now. Um, Meaning that we should do this again, something like this
Yeah,
for.
that's what they said for violet.
Okay. Yeah, we will do
It's
the
in the
same thing.
question.
Yes. Sorry, this is for violet. This is also for violet. The black one for red, and the other one for violet. So something like this. But you understand what I'm trying to say, right?
Yeah.
Yeah.
Okay. Now they said state how the speed of light in glass depend on frequency. Explain how this is shown by the dispersion of white light. Okay. Please write this. Larger frequency results to smaller speed. Larger. Remember when we did um, the diffraction? I made mention to you that the larger the speed, the smaller. Sorry, the larger the frequency, the smaller the speed. That means frequency and speed are inversely proportional. And that's a statement actually. So what's the explanation? The explanation is that violet light has a smaller speed in glass. Violet light has a smaller speed in glass or has a larger frequency. The explanation is that violet light has a smaller speed or a larger frequency. You can also say it has a larger refractive index. Do you understand what I said?
Yes, sir.
Okay. Ella, do you understand what I said?
Yes.
Okay. The last question. The last question we will be solving for today. Sorry, for this. Sorry.
I don't have that question.
This number 9.
Yes.
Ella, do you have it?
Yeah, me too. Nope.
Oh, Ella, you don't have it.
We enter from there to move to paper 6,
Okay.
alternatives
Yeah.
to
Okay.
practical.
Nevertheless, let's see how to do this. I guess that was an oversight. That was an oversight. But let's see how to solve this.
Chemistry.
Sorry?
This is not chemistry.
No, this is physics. This is physics. This is nuclear physics, radioactivity.
Mad.
Okay. The chemical symbol of the element lithium. You would also do this in chemistry, but I believe you should know this aspect because you can't escape this in exam actually. Can't escape this. Um, the chemical symbol of the element lithium is Li. We know lithium has an atomic number of 3, right?
Yes.
That's the proton number. Figure 9.1 is a representation of a nucleus of radioactive isotope of lithium that is about to decay. Okay, this is an isotope of lithium that's about to decay. Write down using nuclide notation the symbol that represents this of lithium. Now, the first thing we need to do is this. I hope you know how to write an element. When they say an element, X, and then this is A, this is Z, this is Z. What does Z represent? Z represents the atomic number. A represents the atomic mass. I hope you understand that.
Yes,
Yes,
sir.
The
sir.
atomic mass, or it could also be the mass number. Now, the atomic number is the proton number. The atomic mass is the proton number plus the neutron number. So the mass number is a combination of the proton number and the neutron number. So from this question now, the what do you call it? The striped, remember we're talking about lithium. They want us to write, this is what they want us to write, lithium. But that's not all they want us to write. They said we should write the isotope. The first thing we'll do is count the striped numbers here, the striped circles. What are the striped circles? How many are they?
There are three.
There are
Three.
3. That
3.
that tells us that lithium has an atomic number of 3. So count all the circles together. Remember I told you that and the I told you that an element has a mass number, that's atomic mass, which is the sum of the proton and the neutron. So if 3 is
Interesting.
the proton, the other ones are the neutron. So tell me then, how many values? What are the values here? What's the total number of circles we have here?
It's
8. So this is what they want you to write. This is the answer for number one.
oh
Here's the answer for number one. Okay. The next thing they said is the isotope of lithium decays by beta. Sorry, do you guys have these soft copies of questions that I have?
soft copy.
Yes.
I think
Oh,
so.
I don't think I have. I think I do though. My laptop.
Okay. Now, this isotope of lithium decays by beta particle emission to form another nucleus. Now, this is something we have different kinds of emission. We have alpha emission, we have beta emission, and we have gamma emission. So, um, I think I will just do a
Now wait,
little.
please start again.
Now, I said we have different kinds of emission. We have different kinds of emission. We have the alpha emission, we have the alpha emission, and it decays by, this is the value, um, helium 2. So this is positive. 4 has an atomic mass of 4, and a proton number of 2. Now, beta emission is, you most times you see it like this: 0, no mass number, and a -1 charge. Okay, -1. And gamma most times, you see it as 0, no charge, nothing, nothing. So these are the emissions we have. Now they said of lithium, this isotope of lithium decays by beta emission. Don't let this thing confuse you. Is the first thing you need to understand here is, if it decays, when you hear something decays by beta emission, that means you have Li, this is 8, this is 3, now it's decaying. If it decays, sorry, I think that means what you'll be putting here, they said using the diagram representation and in the space after the arrow, draw a diagram of the nucleus formed by the decay. Write the name of the particle to a beta particle on the answer line. Okay, with if it decays by that emission, what you now need to do is, they said draw, but you may not understand the drawing until you have understood the decay process. So if this is 8,3, that means we should be having something like this: 0, -1. Okay, and if this is 0, -1, so that means we should be having, I should be having something like 2. I don't know the value. Um, no, this should not be 2. This should be 4. I'm going to put this as X. I'm going to put this as 8. This is actually what it will decay to. Now, the question is, how did I get this? Hello? Are you guys listening? Hello? Ella, are you there? Hello? Hello?
Yeah.
Yes,
I
sir.
don't understand what
Yeah,
you
yeah, yeah.
did,
I understand.
but
Don't worry. I
like
would explain. Don't. I just need you guys to be sure that that you're around. Now, Ella, this is Caris. Can you hear me? Hello. Oh,
get
come on.
somehow.
Are you guys there? Can you hear me?
So how did you get
I know. I would explain that. I would explain. We've not even gotten there. We've not drawn it yet. But I want to
Yes, I
explain
can hear you,
something.
sir.
You can hear me. Good. Now, this is it. This is exactly what I want to explain. this is exactly what I want to explain now. Um, I will need to start from the basis of I will need to start from the basis of radiation, so for you guys to get to catch this. Now, this is okay. I guess let's stop here and let's explain radiation proper. Let's explain radiation proper. So now,
Okay.
so this is just more or less like a class on radiation also, because if you understand this now, it's going to help you to understand other um, every other thing we do on radiation. Okay, so let's get this started. I'm coming. Let me get a video for you guys to understand. It's okay. Now I'm going to play a video, and I'm going to play video so you guys could catch this. Coming, it's coming up. So we would stop that. Can you see my screen now?
Yeah. No.
Okay. Now just watch this 4 minutes video on
Yeah.
radiation and get some notes on this, please. Get some notes on this. Okay. You understand? You understand what you mean by isotopes, right?
Yeah.
That's atom existing in having the
Yeah.
same atomic number but different mass number. Okay? That's what we mean by isotopes. Now, this is lithium. Lithium can exist as lithium. We have three isotopes of lithium here. If you check their mass, their atomic number, which is 333, they all have threes. That means they have the same atomic number, but their mass numbers are different, 6, 7, and 8. Okay, so let's continue.
So please pause.
Okay. Can we continue? Can we continue?
Yeah, I guess.
Okay.
So can you explain it?
Okay. Now, unstable ice, what we say material it's unstable, that means it consists of or is radioactive. Radioactive means that they can decay over a long period of time. That means they can, just use the example of a human body decaying. So that's what we are talking about atoms now. Atoms. So when they are radioactive, now when they are stable, this is why you have if you check the periodic table, the larger elements like polonium, uranium, thorium, they exhibit their radioactive elements, meaning that they can decay over a longer period of time. So that's all. That's just literally what it means. But we've not gotten to the major parts. All these are still explanations. Now, this is exactly where we're going to types of nuclear radiation. Okay, number one, alpha radiation. Okay, You've gotten this, right?
No, please wait.
No.
Okay.
Okay, are we ready?
Sir, no, not yet. Okay.
Okay.
Please pause. Okay.
Okay.
So what do they mean by relatively large?
Okay. So that means the alpha particles are really, what it just means is that they they are large and can be broken down into simpler molecules. But the major thing is this, this
Sir,
same thing, that it can penetrate very far. It can't penetrate very far into other materials. That's the main thing.
sir,
Yes, please.
is he what they mean? What does helium have to do with alpha radiation?
Now, exactly, that's a good question. Look at what it started with. That alpha particles have two protons and two neutrons. Check the periodic table.
Yeah,
Which element has exactly that kind of properties?
helium.
Helium. So that's why we also represent alpha radiation with helium. You can decide, some textbook alpha, use just alpha and put 4 and 2. But other textbook also use helium because helium has exactly that property of alpha radiation. So invariably, we can also write that as helium.
Okay.
Okay, now the main, I don't want to be forced into the main thing because there's something else is going to say, which I need you guys to catch up. That is it. Alpha radiation can be absorbed by a piece of paper. So they can't travel far. So that means if you are exposed to alpha radiation, a paper alone can absorb alpha radiation. So that's exactly what I want you guys to take note of. Okay, but note they are strongly ionizing also. Strong, in fact, they are the strongest ionizing with particle. Okay,
Eh,
You said?
no, don't worry. I don't understand the diagram.
You said?
I don't understand the whole diagram.
The major thing I want you to know is not everything you need. What you need to know is this: electrons, that's beta particles. Number one, they are emitted at high speed. That's because they travel around the nucleus of an atom. They go around the atom itself. That's what you should know. Number two, it has no mass. There are basic things you would need for IGCSE. Electrons have no mass and they have a charge of -1. There are other things he will say again that has to do with its absorption. See, when you talk about these particles, just like we did for alpha particle, number one, you need to know the proton, you need to know the charges, you need to know how ionizing they are, you need to know their absorption, what can stop them. Those are the basic things you need for these particles. Okay. So they are moderately ionizing. Okay. Okay, they can be absorbed or stopped by aluminium. Okay, those are the things we need. This, that. Okay, now let's move.
So wait now. So
So how many
if okay, don't carry go.
neutrons are there?
No mass. If you
So they don't have any.
if we say no mass, what does that mean? When mass number is the sum of proton and neutron.
Oh,
So when we say no mass, you should know what it means already.
So
Okay.
wait, so nothing can stop it except aluminium or what?
Yes. It's you
Okay.
bring a piece of paper that penetrates through a piece of paper or can be absorbed or stopped by aluminium. All right, let's continue. Sorry, Caris, are you in that group?
no,
You don't have a WhatsApp number?
I changed my phone,
Sorry?
my number. I changed my phone and my number.
Oh, please, if possible, find a way of sending it to me. Because if not for that favor sent it to you, you won't have come here earlier. Okay, let's continue to gamma particle. So just probably send the chat to me with your number.
Okay.
Okay, so that's all you need for gamma. Let me know when you're done with that. Okay, I guess you're done.
Yeah.
Yeah.
Okay. Yes, right?
Mm-hmm.
That's we really don't need that much. Okay. Now, okay, that's now having understood um, this aspect of radiation now, having understood this now, okay. So there's another one I would have loved us to watch, but I think okay. For example, now if I'm going to use this, this is not the real theoretical example, but if I use this now and put this as 95, for example, this just and I say this decays by an alpha particle. The question now I would ask you is what and I ask you to give me the value, the mass number and the atomic number of the elements that will be formed. Do you know how you solve this? Now, this is the idea. I want to show you the idea I used for the other one that we did now. This is like balancing of chemical equation, like balancing of equation in chemistry. What you do is this. The sum that you must get everything in the right hand side, that's the mass number of the helium particle, and this new element that decays to form, that forms, must be equal to 235. So if this is 235 and this is 4, this is you just do 235 minus 4 is what?
231.
2,
What do
231. So this is 231. 95 minus 2 is what?
93.
93. So this is the new element that will be formed. So that this plus this must give you 235. This plus this must give you 95. Simple. So if you go back to that, if it was, for example now, if this decayed with beta particle 95, the first thing I like to do is to draw the beta particle first, 0 and minus 1. Oh yeah, you guys tell me what will be the value here?
235?
235.
And 96.
And what will be this? 96.
96.
Do you understand that now?
Yeah.
Yes.
Okay, so let's come back to this question. So you now understand I first wrote this out. Normally, they didn't ask us to write it out, but you have to write it out to understand how to draw this guy here. Now, they gave you this one as, you already know that this is 83. And they said it decays with a beta particle. The first thing you write is the beta particle, either the E or this. This is 0. This is minus 1. So what would be the value here now? What would be the value here? This would be what? 8, right?
8 and 4.
And what will be
8
here?
and 4.
This will be 4.
4.
4.
Simple. Now, you now know that the mass number is now, that means the sum of the proton is 4, the neutron is 4, right?
Yes.
Okay, so what you do now is you clear this off. Now you draw this again. You draw this again. It's going to, you know that the proton number is 4. This one is here. This one is here. You shade it instead of 3. You know, remember it was 3 here. It will become 4 now. You put 0. You put the 0. You put another 0. You put another 0. You shade it. You put another 0. So we are going to shade one now. Let's shade this one. Any of them, you can shade anyone. So this is exactly what they ask you to draw. This is it. Do you understand that now?
Yes.
Ella, do you understand?
Yeah.
So this is the decayed particle they wanted you to do. They were, and funny enough, because they know you needed an understanding to do this, they gave it 3 marks, a very high mark. So that is just it. So you see, radioactivity is actually very easy. It's not as difficult as the name sounds. Now they said a radiation detector is set up in a laboratory where there are no radioactive samples. On 6 separate occasions, the detector is switched on for 1.0 minutes and the background count is recorded. The counts are 2, 7, 25 these days. State why all the readings are not identical. State why all the reasons are not identical. Please write. The reasons why the readings are not identical is because of radioactive emission. Because of
So
radioactive
how should we
emission.
write it? Because
Sorry, you don't have the, oh, you don't have it. That's true.
uh,
You don't have it. But the reason why, the reason this is that is because of, it could be because of radioactive emission. It could also be because of the background radiation, and it could also symbolize that the decay is random. The decay of these samples are random. Suggest a possible source for this background radiation. Suggest a possible source. Let's go back to the question. Suggest a possible source for this background radiation. The source of radiation could be, number one, could be rocks. Rocks could be reasons why things decay. Buildings could also be a reason. The earth could be a reason. So source of
And
radiation,
how?
I'm giving you different sources of
No, like how are they sources?
how are these sources of radiation? Now, how are these
Mm,
sources of decay? How are these sources of
yeah.
decay? For example, um, put your body on the ground and don't wake up again. Why? How come?
Ah,
What makes the body to decay? Because it's not active. The earth. Put a human body to the rocks that is dead already. That body will decay. So as long as the person is on earth, so that's why I'm saying this. I'm just talking using humans now to illustrate this
okay.
because that's the simplest one that our minds can actually take. So now for elements now, the sources now, different sources of decay, sources of decay which could lead to radiation. It's the earth, even space also could be a source for an element to decay. So this they said suggest a possible source for this background radiation. It could be the earth, it could be the rocks, it could be the soil, and that is it. Okay, I'm not going to do this because you will get more confused. Because there's something else I was meant to show you guys. There's something on radiation I was actually meant to show you again, and I think our time again is almost up. But I believe we've done something very, very we've done something very, very smart today. So the next thing I'll leave you guys to do, I'll need you guys to do, please, if this thing goes off, just come back again.
Okay.
Do you understand? Because I think it's about going off again. But what I want you
Yes, less
guys,
than 1 minute.
yes, less than 1 minute. I think what I'll need you guys to do is, if you could try, okay, there's something on